Okay, I set it up on the surface plate of the magnet. It's nice and tight on there. Should be good enough. Shouldn't move off. And as this is brass and soft steel, I have my coarsest aluminum oxide wheel on there, and it's a good opportunity to test my fog buster. I decided to buy a fog buster mist cooler for the surface grinder, as it's not set up for flood coolant in any way. And I had before the Noga Mini Cool, and I didn't like it. It's always a hassle to set it up because it's a siphon system which works after the Venturi principle, and it pulls the liquid in by itself, and that doesn't work very well. So I got the fog buster, which has a pressurized coolant tank. And as soon as you turn up the air, coolant goes to the nozzle and it's hassle-free. So let's see if we can grind this magnet here down. Okay, turning on the air for the fog buster and adjusting the nozzle so I'm aiming at the leading edge of the grinding wheel, which does all the work. And starting to take a pretty deep pass to clean up the surface. The brass steel mix grinds quite well. I was worried that it might glaze up the wheel, but the fog buster did a pretty good job to keep this under control. As you can see, the surface is rather good, and I'm very happy with the fog buster. The coolant, I'm using a water-soluble oil designed for grinding. Works very well. I have no glazing on the wheel, and the air consumption is in a reasonable amount, and yeah, seems to work quite well. So I ground the first two sides parallel, and this is the setup to grind the third side square to it. And let me break it down. I have one block back here that was just blocking, so my magnet doesn't go that way. Then I have a ground precision block here, where the magnet is stuck against with one of the machine surfaces, so we're square to the world. I have a dowel pin down here, which acts as kind of a parallel, but doesn't transfer very much magnetic force into this magnet from the mag chuck, so it doesn't distort the setup. And I have parallel over here which blocks in the magnet itself. Then we have this dowel pin down here. And what sucks with the wet grinding, of course, is the cleanup. Each part needs to be wiped, and this is the diamond that I had back here on the table of the surface grinder to redress the wheel. Now we can take off this guy without sliding it. And we have this side ground, this side ground, and the side which rests against this block is also ground now. And these setup magnets, as we call them at work, they look nice for about half an hour, and then they are all scratched up because they are brass and soft steel. Or in case of those at work, they are brass and ferrite magnets, which don't even hold a sharp corner. They are so brittle when you use them, the ferrite magnets break out here at the corners. Okay, I'm pre-grinding the last surface, so the magnet is roughly squared on all sides and pretty much cleaned up. There are still a few areas where the surface didn't clean up perfectly, but I'm going to do that after the next step, not right now. Okay, I ground all four sides of the main sides of the magnet clean and square. I have a few spots where I need to come back and resurface it, but they are mostly cleaned up. And before I go on to anything else, I want to pin them. This thing freaks me out. I really fear that it might come apart because it's only glued together. So we will set it up on a milling machine and drill all the way through in the corners. Hopefully my drills are long enough. Let's see, this is a 3mm drill, yeah. Stupid me. This is pretty much not long enough. 4mm would be long enough with some digging around, but yeah, this one. And as you can see, this thing is ridiculously strong. Way strong enough for the purpose I want to use it. I'm not going to set this flat up because I would have to slide it off. In that configuration I can break the parallel loose, but that way I would have to slide it off, and that would scratch the magnet right away. I'm still thinking about how to drill this through. I don't want the pins to be too close to the edge because this will see some refacing from time to time. So I'm not sure what I'm going to do about that. Okay, we're over at the milling machine and I want to set the magnet up for drilling, and I don't want it to stick to my vise like crazy, so I'm putting some 3mm PVC plate between the vise and the magnet. Don't have to crank down like crazy. Okay. As you can see, I managed to break it apart while I was drilling the holes to stiffen this guy up. I guess we make 2 of these magnets right now. I will pry off this piece of brass with the magnet in it, and we will pin them. Drill the second hole, pin them again, and then we will grind them all over. And then we have half-sized magnets, but they are still rather strong and still useful. And maybe it's even a good thing that they are not that brutal strong as the big one. And they are still useful for alignment. I'll show you later what I mean by alignment. Okay, we should be able to pry off this last piece of brass with a razor blade and a copper drift. I can see this hook go horribly wrong. Horribly wrong in the sense of cutting off my finger. There we go. Didn't hurt at all. So there was one of the brass plates with the magnet. Went into the trash, or at least close to the trash can. Clean off the remaining glue. Now we have two smaller magnets. Yeah, we will use this 4mm brass rod. We will Loctite it in with Loctite 648 retainer, bearing retainer, so this pin is never going out again. We will need about this much of material. I will saw off the end here. Okay, I put in both of the pins, or I drilled the second hole and pinned it on two sides, so these should be reasonably strong now. I put in an awful lot of Loctite 648, that was a bit messy, and now I have two precision magnets that I just need to grind up as a pair, and then I can use them in the shop. And yeah, let's go to the grinder and do the final grinding on them. They are about 20mm, and the next thing will be to build a demagnetizer for the shop, because everything's getting magnetized since I have a surface grinder in the shop with with a mag chuck. So now we are grinding the magnets as a pair, so they are perfectly square to each other and have exactly the same dimensions, so you don't have to worry about their orientation when you use them. Okay, I got the bad side where one of the steel segments was very low cleaned up by taking off 0.3mm. Surface finish is good, and we have still a lot of material left before we hit into the pin, into the cross pins through the magnet block. Let's flip it around, clean up the other side, and then we will grind the other pair of surfaces to match the thickness of this, so they are matched pair in every direction. And I will just take off 1/100th of a millimeter on this side. Cleaning up the last surface without changing the height adjustment on the surface grinder, just to make them perfectly the same. So okay, the magnets, I ground them on all four sides and I consider them finished right now. I want to show you some uses of these. What I use them at work most of the time is as a vise stop. I have the same style of grinding vise on my machine at work, and as I work mostly with plastics and non-ferrous metals, I like to use these as a vise stop. Just drop them on the side of the vise. Drop in your parallels and you're good to go. They work also very good for ferrous metals or steel as a stop, because they actually suck the part against the stop, but then we have absolutely be sure that there is no remaining dirt on the magnet or on the part, or you don't have a burr anywhere. Then this works also for steel very well. They have much more uses in setup. If you want, let's say you have this part and you want to have it reference of the top surface, and top surface should be level with this with the upper face of the jaw, of the fixed wise jaw. You just drop your magnet on top, drop the part against the magnet, and eventually lock your vise down. So there we go, remove the magnet, and now it's dead flat with the surface of the vise. So it's a good alignment help. You can also use them like this, and the part against here, and this will square up the part in the X direction. In the Y direction it's squared by the vise, but in the X direction there is nothing to align it except for the magnet here. So now it's standing up perfectly vertical to the vise. They are also good for assembly work, or aligning work for assembly, whatever you want to call it. Let's say you want to join these two pieces here, and you already drilled and tapped the hole into them, but you want to perfectly align them so you can put in dowel pinholes and fix them in their location. Then you can also use the magnet. Just use 2 of them, 1 on each side, make sure they are clean, and get the second part up here, and they are aligned to each other perfectly. If you had a third one, you could put one over the end here, and now you could clamp it down or tighten the screws if there are screw holes in it, and then drill ream it, and you have perfect alignment. That's a technique our toolmakers at work used way before wire EDM and jig grinding. So that's the I would call them Toolmakers magnets because they need a name, and that sounds quite cool. So that's the Toolmakers magnets first prototype finished. I'm very happy how they came out. They are plenty strong with even three magnets in there. And yeah, next thing will be to make a bigger set of these and make magnetic parallels without magnets in them, so they are just transfer blocks. So thank you for watching, and see you next time.